So the title is slightly different, but the paper is the same. I thought this is a much better title. So what I'm going to inquire is the nature of multiplicity. So economists, some hate multiplicity, others love multiplicity. If you have model with multiple equilibria, you can give account of many different outputs. But at the same time, you cannot predict which output you are going to observe, because basically if you have multiple equilibria, beliefs of agents about which output is going to happen is undeterminate. I mean, is not determined by fundamentals. You have to introduce some spot structure or whatever. So what the Morris and Sheen propose is to have a global games view of multiplicity. So they propose to rethink multiplicity as the artifact of two simplistic assumptions. One is economic fundamentals are assumed to be common knowledge, and the other is economic agents are assumed to be certain about each other's behavior in equilibrium. So if you want to violate both, you have to introduce private uncertainty about the fundamentals. So a clear example is what has been explained by Gabriel before, is the currency attack model. So in this model, if the information structure is agents know the fundamental, then multiple equilibria exist. 3 equilibria, actually, one in which everybody attack, nobody attack, and a mixed one. Then Morris and Sheen demonstrate that when agents are private and uncertain by the fundamental, then multiplicity is pinned down. Okay? So if you add private noise, then you go from 3 equilibria to 1 equilibrium. Then Galetos, Werming, and Helvig others show that when agents also receive endogenous public signals, the original multiplicity is restored. So under this informational structure, so adding an endogenous signal of aggregate expectation and fundamentals that is public, then this restores the original multiplicity. That is, we go from 3 to 3. So what this paper is about is a slightly different information structure that is about private uncertainty on endogenous aggregate variable. So private signal of an aggregate endogenous state. Okay. So I'm looking at the possibility that private rather than public endogenous signals can confuse agents and not coordinate agents and be a source of multiplicity in the context of models that exhibit equilibrium uniqueness rather than a multiplicity under perfect knowledge. So I start with an equilibrium, with a model that has a unique equilibrium under perfect knowledge, and I want to know to which extent private uncertainty that is on endogenous state of the model can trigger multiplicity. So in this paper, I identified the conditions under which an endogenous information structure allowing for infinitesimal departure from the assumption A and B can indeed invalidate the uniqueness of equilibrium. So take the 2 A and B conditions that I showed you before and violate it in a situation in which you have an endogenous information structure. And I show that small enough private uncertainty on endogenous aggregated state of the economy can generate a multiplicity of always 3 equilibria. Whereas when this uncertainty is null or large enough, a unique equilibrium exists. Okay, so I start with a model that has 1 equilibrium, I perturb no matter how little, and I end up with 3 equilibria. But then if this private uncertainty is large enough, then I have again uniqueness. So in some sense, it reverses Morris and Sheen argument, but still maintains some flavor in that more information is bad as more private uncertainty restores uniqueness in a sense. So it's not a complete reverting. But I do this having in the background a micro-founded macro model. So my result is really about an information structure. But the paper also wants to inquire to which extent I can recover this information structure from a general equilibrium model. So the signals does not come down from the sky, but the information is acquired through market transactions. So all the informational friction I will consider have a fundamental nature, as in a recent paper by Amador and Weil. Okay? What is different from Amador, by the way, Amador and Weil have a model, so they are not interested in multiplicity instead, they're interested in the welfare properties of public versus private signals. But they show in the online appendix that also multiplicity can be obtained from private uncertainty lying in two strictly positive boundaries. And also, Gabriel has a paper with Céline Rochon, Ganguly and Yang shows a kind of similar result. So just to be clear on the result, so here I have the dimension of private uncertainty. If so private uncertainty is 0, then I have a unique equilibrium. So Amador and Wells say, okay, there is an open interval in which there is multiplicity, and these boundaries are away from 0. This is Amador and Weil and de Grange and Ganguly Yang. So, and the paper presented by just 2 days ago, or yesterday, I don't remember, it fits in this kind of discussion in the sense that, I guess, then you can confirm, that in your paper, this condition, so you have multiplicity for 1 point. So there is 1 point in which you have multiplicity. But I should add that what is interesting about your paper is that in this other range, you don't have uncertainty. So this could be something that should be properly framed in this discussion. But what is my paper, so what is the result different in my paper is that the existence of this kind of situation is shown as an additional result. But what I'm interested in highlighting is that I can obtain something like this. Oops, sorry. So that is, you lose uniqueness no matter how close you are to 0. So it's just an open interval in which 0 is the boundary, is the frontier. Okay. So what I'm going to show you is the micro-founder macro model. So this model that addresses the information structure that I'm going to discuss in the second part of the talk, just highlighting some element of the analysis, and then I conclude. So the model is really built up with standard element. So there is a continuum island. In each island, consumers maximize utility. It's a money and utility function. The model is dynamic, and there is nothing really non-standard. Just focus on this element here that is an endowment that is given to the consumer each period and perish in 1 period. Okay, and so it's renewed each period in each island. It is an endowment that the consumer can sell at a price R. Then, in the island, there is a competitive final producer maximizing profit. And this producer use capital and labor that are island specific. So they cannot just buy these factors across all the economy, but they have to hire the labor that comes to the, from the consumer in the island, and the capital that is specific to his own island. And then there is a competitive intermediate producer that maximizes profit, that has a linear function, a linear technology, sorry, that is using the endowment of a consumer to produce the island-specific capital. But the endowment is not island-specific. So is going to acquire this endowment in a global market across islands. And then is producing something that is very specific to the island in which it's going to sell. Okay? So from the side of the input market of this competitive intermediate producer, there is a global market. On the side in which instead he supply, there is an island-specific market. Okay. So there are, and the final production, so the competitive final producer, is implemented only once the input markets have cleared. So there is final producer in the island, hires labor-specific and capital-specific. Then when the input market have cleared, produce. Shocks. So here I take just some technical tricks, may want to say, from Amador well, in the sense that, so the model is dynamic, but really I want to focus on a static signal extraction problem, as they do, because I want to make a point in this literature is about static extraction problem. So there is one shock, so there are 3 shocks hitting at time 0, and then they will be permanent, okay? So they will not trouble agents through time. Of course, you can think a setting that repeats itself each time, but you have to adjust some little technical detail. So there is one shock in the productivity of an intermediate sector. So when this intermediate producer acquire this unspecific endowment, then in the production, there is something specific to the production of the island-specific capital that blur the price of this. And the supply of money available in each island is dropped from an helicopter of the central bank, just is idiosyncratic across islands, okay? And the consumer have to go to the bank in their own island. Okay, and then an equilibrium is just clearing of all the market, conditional to the information agents have, so nothing really special about the equilibrium definition. So this summarizes really the information structure and the flows of information in the model. So there is an injection of money that has an aggregate component and in the island-specific component that is on the consumer worker that is demanding money, okay? So this consumer worker supplies labor to the final producer, and this transaction is island-specific, and is going to reveal a price that is island-specific, the wage in the island I. And this wage, this transaction, is going to convey information about this. So if you go in the paper, there is I analyze the first-order condition, so this is the case, okay? So this guy has to forecast the price at which he will sell the production after the input market clear, having observing the price wage that is specific in the island. But then he receives information from this other transaction. So there is an intermediate producer that hire endowment across islands. And in this transaction, there is a price that is global and reveal what? Reveal actually the aggregate component that is what is needed to forecast these 2 global prices. The price that has to be forecasted by the final producer and this R. But the final producer cannot observe directly the R that will be revealing the epsilon, but is going to observe a price that is island specific. This is going to reveal the R with a little noise. So the private uncertainty on the endogenous state is the variance of this noise over this aggregate endogenous state. This is R. So the information about the aggregate shock is, at this stage in the economy, is here. But this guy cannot see directly this R, can just have partial information. So the blue arrow are the global market, and he cannot observe this directly because it's going to produce after. The green arrow is information that is island-specific and is exogenous, does not depend on expectation of agent. Instead, the red one is the endogenous signal that is private. So it's endogenous because it is a signal about an aggregate state of the economy that is out of there and that is useful to predict price. So this is the information structure, okay? It's conveyed by the market. Now, we can go deeper and specifying what is the price. So the uncertainty variable to be forecasted is this price that is equal to the aggregate shock plus beta times that multiplies the distance between the average expected price from the fundamental. So if everybody expects the fundamental epsilon, then the price is epsilon, okay? So this is just to say that if under perfect information, in this market, money is neutral. So you expect the price, the global price to rise with it. And this is the aggregation. So notice that beta is less than 1, okay? Actually, it's negative. And so this is a micro foundation of the Cobweb model. under different perspective. It's exactly the same. So you can think about that as a decoupled model, nothing different. What is different is the information they have. What they observe a price, the liter Ri, that is nothing else than R plus the disturbance. And then they have some exogenous stuff, so a direct signal of the aggregate supply shock. But what is the R? The R is a global price, has the same structure of the price that I showed you before. So it's going, if the agents in the economy expect the price to be epsilon, then also R is equal to epsilon, because of neutrality of money. But if there is a difference, then the R reacts to that. How it reacts? Reacts with a key, XE, I don't know how we call it, is bigger than 1. So now the people here that are interested in dynamics and learning and stuff will understand that here there is a point, okay? So why this key is greater than 1 exactly for this price? Because what occurs is, okay, the money supply is shrinking the labor supply, okay? So in a positive shock, the worker feel richer, they provide less labor. But the producer, they don't expect the price to rise. So figure out, in the case they don't have any information. So what happens is that they hire less labor, okay? So the wage is going to increase, but not that much. They hire less labor, and so this affects the productivity of the endowment. And so they are lowering the demand for the endowment indirectly in the market. And the endowment is in fixed supply, the price for it decreases instead of increasing. Under perfect information, it increase. Under no information, decrease. And this is key. Okay, this is given by this coefficient here, because you can see if this is 0, then you have something negative. Okay. So this is why it's useful to have a micro-founded model, because what I'm going to say now about the information structure can be interpreted in terms of general equilibrium models, understanding what triggers what. So now let's go to the analysis. And I'm simplifying now to clarify what is the central point. So now the object I have to forecast is this price, is what I showed you before, okay? And now I'm taking the case in which agents have only the endogenous signal, okay? So the endogenous signal, remember, was R, depending on the expectation, aggregate expectation, plus the aggregate shock, plus some idiosyncratic disturbances. So you can rewrite the signal just by dividing for a coefficient in a form that gives you expectation plus some aggregate component and individual component. Okay, you can do this. Okay. And so you have your information summarized there. And so why you want to write it in this way? Because now that Z that is here is the covariance of the fundamental component expressed in terms of the overall volatility of this component. So it's the covariance with the epsilon. And this sigma is the variance of the private noise, also in terms of this component. That is the ratio that really matters in this problem. And now notice that in the case in which I have, so if I try to recover this from the price, then this Z will be less than -1. So whenever I talk of this coefficient being less than -1, it corresponds necessarily to a key that is greater than 1. So to the case of my price of the endowment that is doing this strange thing. So now we did the forecasting rule. So take my price is equal to something that weights the endogenous signal. You can integrate from both sides and expressing it in terms of aggregate expectation. So you can plug in the individual forecast and obtaining something for the actual low motion. So everything is there. Now it's just a matter of calculating the fixed point. So the optimal BI that is responding to an average profile of the beta bold. Why I like this way to put things is that because people familiar with the learning approach can think this as a T-map. So this is my optimal coefficient given the actual coefficient. Okay, this is what would be optimal to weight if the evolution of the endogenous variables in the model is responding to this average beta bold. It's composed by two pieces. One is fundamental effect, the other is payoff externality effect. I could kill the beta and just talking about this element here, that is what matters. So what I'm going to show is that under the z less than -1 and with the beta less than 1, there always exists a threshold that is, doesn't matter, such that if the private uncertainty is between 0 and this threshold, so my case here, this equation has 3 real distinct solutions, whereas a unique one otherwise. So now I'm going to show the map just killing the beta, showing this part, okay? So how will it look like? Take the private uncertainty. If the private uncertainty goes to infinity, then no matter what is here, this has to be equal to 0. If the private uncertainty instead goes to 0, then you have a line, okay, with a slope of -z. Okay, so it's this. With uncertainty very high, so this line approaches the x-axis. As the private uncertainty increases, then there is the possibility that 2 equilibria show up here, 2 fixed points, okay? And what is a necessary condition for this is that the slope of the line that is going to converge this curve is steeper, is greater than 1, okay? So in this case, so in the case in which the general equilibrium generates private uncertainty about a price that is reacting in the way I explained to information, then you have a multiplicity here. So it's a very clear condition. But notice, again, I want to stress the connection with the learning and the dynamics. So as I said, here I'm plotting something that is like a T-map. So what I'm saying is that in the case of perfect information, when I have just a line, I have a unique equilibrium here that is unstable. So I have a cobweb that does everything like a standard, but has inside some mechanism that is amplifying the reaction to information. And actually, the striking result here comes from the fact that in perfect information, this equilibrium is unstable. So, and if I perturb this equilibrium, so I have now a shape here, I have 2 other equilibria that are learnable. So what I'm saying is that the situation is the following. I'm at the peak of a mountain, and I have a ball here. I'm saying I can put the ball, but the situation is very unstable. So the earth has to be fixed for this to maintain. If I have a little movement of the earth, then the ball is going to fall. It's going to follow here, here, and those are stable. But the earthquake is too strong, then I don't have a mountain that is destroyed. I have just one ball. So this is what is happening here. And actually, I think partially respond to the critique that in some way, adaptive learning gives, for example, a 0-1 response. Either it's stable or not. In this case, I have a further dimension that is private uncertainty. You say, look, if you have an equilibrium that is unstable and adaptive learning, you perturb it, then the model generates 2 stable equilibria and give a response to that. So here, just the overall picture explored by numerical analysis, where I have in the space of z less than -1 and beta ranging from 1 to -infinite. So the white region is the one with multiplicity. So if I'm here and I generate multiple equilibria, it's sure that I'm going to generate here and here because it's going to shrink, okay? And so there is a certain threshold after that I'm okay. And then what are these other regions? I told you that I show you a model, an analysis in which I just considering endogenous information. What happens if I have the other signal as in the model? So it happens that exogenous information is shrinking this multiplicity area in this way. So as you get more information directly through an exogenous channel, then this multiplicity shrink. Okay, but still you maintain the qualitative behavior around here. So still there is a region in which this happens. Now, so I have this result. So when I consider exogenous and endogenous, I have some boundaries here that are expressed in my z and beta component, okay, and beta coefficient that have meaning in the macro model. So now I'm curious to go back to the general equilibrium model and understand what the hell is this, okay? And it turns out quite surprisingly that this condition turned out in this. It's a very simple condition. That is, exogenous uncertainty, so the blurring from the exogenous signal, has to be greater than a simple combination of the coefficients that shape the concavity of my problem. So here I have the elasticity of consumption in the utility function, no, labor in the utility function. Here is the one of consumption, and this is the cobweb coefficient. So this, in the case of extreme concavity, okay, so in the case of linearity, let's say, okay, let's start. So I have alpha equal to 1, this is 0, this is 0, actually this is 0. So it means for every uncertainty here, I obtain multiplicity. As the model becomes more and more concave, then my condition became more and more stringent. This is intuitive. As the problem is more concave, I expect more sticky endogenous variable instead of volatile one. This concludes my talk. So I have investigated general condition in which small enough private uncertainty in aggregate endogenous state can trigger a multiplicity of equilibria in otherwise unique equilibrium model. In particular, arbitrary small private uncertainty on a global place which exhibit opposite reaction in the case of no information or perfect information can sustain multiplicity of equilibria. This is an exact characterization of the result of the paper. Oops. Future line of research, I say something about equilibrium selection, and of course the frontier will be dynamic signal extraction problems. And that concludes.